Chapter 14, sample problem number 10. Two identical point sources are generating waves with the same frequency and amplitude. The two sources are in phase with each other, so that the sources generate wave crests at the same instant. The distance between the two sources is equal to 1 1/2 times the wavelengths, 1.5 lambda. That means that every box here is half a lambda. List all of the labeled points where the waves from the two sources will constructively interfere, and then list all the points where they destructively interfere. Remember, they will constructively interfere where they add, which means that they are one wavelength apart from each other at the point of interest. So for instance, if we look at point A is one wavelength away from the left source, and it is 1, 2, and a half wavelengths, 5/2 wavelengths from the right source. Just because it's hard to keep track of these in my eyes, I'm just going to go and make these very bright, hopefully, so I can keep track of that's what I'm measuring from. So we see that the difference is 3/2, right? So the difference in wavelengths for A is 5/2 minus 2/2, or 3/2 lambda. So A will go in the column of destructive interference. All right, so let's clean up and see what happens with some of the other points. Oops. I'm going to highlight my... Again, we're talking about this source and this source. And so if we think of the distance of B, this is 1/2 wavelength, and this is 1, 2 wavelengths. So the change in wavelength is, the difference in wavelength is 4/2 minus 1/2, or 3/2. Again, not an integer multiple, so in fact, the exact opposite of an integer multiple, so again, this will be destructive. If we do C is going to be a little trickier because now we need the distance from the point to the source we care about. This is 2 wavelengths, that was easy. But then we have to say, oh wait, we have over here 3/2 of a wavelength. And what we care about is this distance. And that's a little annoying. So if I think of this as 4/2, then I have a 3, 4, 5 triangle, but there would be a half again, right? There'd be the same half. So our distances here, our delta of the wavelengths here is 5/2 lambda minus 4/2 lambda, or 1/2 lambda. That's again destructive. Starting to see a bit of a pattern here. If we talk about part D, point D, we have a value of 1/2 and a value of, 1. So delta lambda is 1/2, which is half integers end up meaning, or half odd integers end up meaning destructive again. For E, we have, well, that's 1, but that's 1/2, so that's going to be the same. It's also destructive. And then for F, we have, well, it's the same as C, right? It's the same shape as C. So we end up with that all of them are destructive and none of them are constructive, which is maybe not particularly illuminative, but there we are.